Well, I'm working on this smoke assembly. Let's see if I can do this without knocking my camera off its pedestal here. There we are. That's a little better, I think. This is a trigger assembly that I am building. I did a prototype of putting the reverse fingers on a piece of plastic and then having a drum go around. Let me show you this. Get this, wrong screwdriver. This really came out nice, I thought. Comes right out, no worries. Yeah. There we go. This is a drum gear that I put together. As you can see, it has a little stripe of metal there, and it is the distance of two of these, we call them fingers, for the reverse unit. And when this drum pivots and goes past that, it creates a connection, what we call a trigger, okay? And we want to know when this goes by so that we can send a signal to a smoke fan, or to a soundboard, so that we can then create a pulse of energy to the fan motor and create a puff of smoke. We also send a pulse to the soundboard to create a sound of an exhaust, steam exhaust from a steam engine, like a chuff. So you go choo, 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 choo. That's the whole thing. Anyway, we're mimicking that signal with a new device, and this is the prototype. This is the, I wonder if that would work. And it did. So now I'm building the one that I want to use, and this is just a half. Okay, there's going to be one over here, and I'm fitting it. I'm not done fitting it. It's still going on. But as you can see, if I line this up and the pivots, it actually seems to act like it would work. So that's what I'm doing here. I'm just fitting this together so that I can jam it in like that. There we are. And then just sit and watch this and rotate it and see how it connects, and it looks like it's going to be okay. Then we have this thing that goes on top, and there's a screw here and a screw here, and they're a little different. Oh, I didn't drill this one out either. Ah, heck. Well, you know what that means. It means it's going to be a manual assembly here, but that's okay. We got it. We got all the tools we need to figure this out, I think. Not that one. Yeah, there it is. Okay, we can get it. Okay, so I'll bring this in. I'll get the other one if I can find it. It's laying around somewhere. This comes in. This is the front. This is the back. This goes on like this. Is that right? Or does it go like that? Yeah, it goes on like that. That's right. It goes on like that. Is that right? Jeez, I took it apart already. Yeah, it was stuck to the motor. Oh, okay. Okay, here we go. This goes in here. And there's another screw laying around somewhere. I may have misplaced it. I don't know. I don't see it handy. It's still in something? No? It's come out. Here, is that it? Oh yeah, that's it. That goes in here. And then of course you have to use a different type of device, which is this one. He goes in here. May not make it all the way. I haven't checked these depths. I can cut these screws. I have a screw cutter if I need it. Yeah, looks like it's going. Looks like it's going. Check it out. Okay, there it is. Bolted up. All right, now I'll probably have to take it off because this doesn't fit. You gotta lay it on top. How dumb are you? No, just the gear. That's all. Just take the gear off. Always something. Oh, I forgot. You gotta put these in first because it is so tight. This is what goes into the DC can motor and gives us a little extra space for this gear. You'll see in a minute, maybe. There we go. Now you put it in, find the holes. There they are. They find me, I find them. There we go. Alright, now then. Now the test. Ooh, it looks like I might be a little off on my hole. I used a file, but I used a file, I just know that, okay? Let's get something a little more robust here, okay? This is the second one, so you could say this was a proof of principle. This is the alpha setting, and I've only got half of them, and I'm going to see changes I need to make already, but that's okay. Alright, now if I rotate this shaft down here, that should rotate up there, and it's a little on the snug side. It acts like it's not quite centered. It looks like it's centered, but ooh, something is either bent or not in alignment. Oh, that is tight. This is this gear set has been working. I think it's a little off. I see that it's a little off in the alignment, and it may be catching somewhere. Alright, well, more work to do. But at any rate, this is progress, okay? It did look like this. I'm taking this plate off because I don't know. Maybe I'll put it back on. We'll see. I wanted this to be able to go on the flyer motors as well. So if you have the armature up here, there's nothing to get in the way. So you could run this on flyer or not. Now the next step is I'm going to add this wing piece here over here for the other set of fingers. So you have two sets of fingers, one for the sound, one for the smoke, and then I'll work on why this rotates hard and stuff like that, and I'll just keep chugging along. So there'll be a alpha 1. This is alpha 1. This is proof of concept, alpha 1. We'll do another alpha, then we'll see, and I'll get it where it's smooth and the dimensions are correct. But this is pretty close, and so this would go in here. Yeah, fits in like that. You screw this in, and this gear will turn with this wheel. This turns at half the speed, so you're going to get 2 pulses here and only one, in one rotation. So you're going to get 2 chuffs and puffs per rev. It's an idea. I mean, it's a little more realistic, though I thought I'd try it that way. And then on this side, we'll have the other finger mounted, so you'll be getting the 2. And there might be room to use the lid of this, or maybe what I thought I could do is cut this off on an angle. I could put one of our PC boards in there, you know, sort of like that, or another PC board on top. And it depends. If we have fields up here, this is all dead space. But if the fields are not here, like this in the can, I can put a PC board here too. So we can put a couple of PC boards there, and we got a new you know, hard to explain this, but this is our new smoke. This is what we call Smart Smoke. Sorry, you can't see it very well, can you? Smart Smoke. This is a sensor that's down inside here, and it measures the temperature. These are the heater coils that warm up the heater inside, and that makes the smoke. And there is a PC board. We call it Smart Smoke, and it measures the temperature down inside, and it manages that temperature depending on the fan, how fast or how frequent the fan pulses. So the heater has a temperature, it warms up, there's smoke, and when you start the engine, this fan has what we call idle speed or setting at rest. It's a very lazy, slow speed. It doesn't take that much energy, so you get nice smoke. And then as you speed up or you take off, it starts pulsing. The fan blows the smoke out, but it also cools off the heater. So what this senses is, hey, this is getting a little cooler down here. You're down around 100 degrees centigrade. Maybe you should add some more energy. And so this board that we have increases the energy until this temperature gets up around 140 C. And then it says, okay, that's nice and warm. That's where we want to be. Now you can pull back on the energy. So then we pull back on the energy. So this is what's called closed loop control. We manage the temperature between 100 and 140 degrees centigrade, and that will work in our smoke, and the fan can go off and on, whatever, and the smoke will not disappear or become real heavy, and that trigger of this motor is all driven by this gear here. Meanwhile, we got the chuff sound coming down, and that's all part of that as well. So this is the new thing we're working on. Okay. Just thought you'd like to see some of it. I don't know. It's fun for me, yeah? Okay, I gotta go. We'll talk to you later. Bye.